Hello everyone, I welcome you all in the next video lecture of 12th class NCERT Mathematics. In this lecture, I'll discuss question number 6th, 7th and 8th of exercise 1.2. So without further ado, let's get started. So the question number 6, what it says, set A we have, set B we have, and let F equals to, so we have a collection of elements in the form of ordered pair 1, 4, 2, 5 and 3, 6, and they said it is a function. They already given it is a function from A to B, and we need to prove that it is a 1 function. Okay, so what we have here we have function A to B, it is defined, and one more thing, how they give f is 1, 4, it contain 2, 5 it contain, and 3, 6 it contain. Clear? So what is the meaning of 1, 4 belongs to f? It means that, what it means, f of 1 gives value 4. It means f of 2 gives value 5, and what it means, f of 3 gives value 6. Clear? So f of 1 give 4, f of 2 give 5, f of 3 give 6. It means that different element of A gives different image, It means that f is 1 function. F is 1 function. Why so? Because which condition is true here? Which definition is true here? For any x1 comma x2 belongs to A with x1 not equal to x2 implies f of x1 not equal to f of x2. Clear? F is 1. This is the reason behind that. Okay, I hope you understand this question. So move to the next question, that is question number 7th. Question number 7th is here, the question number 7th. In each of the following cases, state whether the function is 1 onto or bijective. It means one by one we need to check both the things, 1 then onto, and then if both the things are true, then we say bijectiveness. Okay, so first part I will do here. Function is defined from a set of real number to a set of real number, and they define as f of x equals to 3 minus 4x. Okay, so for 1, what we need to do? For 1, how we can prove 1? Let two elements we need to take, x1 comma x2 belongs to R, and one more thing we need to assume for 1, f of x1 equals to f of x2. Clear? So what is the f of x1? F of x1 is 3 minus 4 x1, and this is 3 minus 4 x2. Okay, 3 cancel, minus 4 x1 equals to minus 4 x2, and what we have from here, x1 equals to x2. So it implies that f is 1 function. F is 1 function. Okay, done. Now 1 is complete. Now for onto, what we need to do? According to definition, let y belongs to R. We need to choose an element such that there exists x belongs to R. This is your codomain, and this is your domain. Okay, because here both the things are same, that's why I mention here. let y belongs to R such that there exists x belongs to R f of x equal to y. So from here we need to find the value of x in terms of y. So what is f of x? F of x is 3 minus 4x. What we have? 3 minus 4x equals to y. Okay, so how we can find 3 minus y equals to 4x? So x value from here 3 minus y upon 4. This is your x value. So we observe that for any y belongs to R, for any y belongs to R above x is defined and also that x belongs to R, that is domain. Okay, so it implies that for each element of domain of codomain, each element of codomain we have pre-image, we have pre-image, implies that f is onto. Okay, f is onto function, so implies that f is bijective. What is f is? I'll change the color, I will write a different color. Implies that f is bijective. Done. Now next question, what is our next b part? What the b part said? B part is this one. Function is again defined from R to R, but now function is changed. Function f of x equals to 1 plus x square. Okay, yeah, here we can do second. Right. What we have here? See, function is defined from R to R and f of x is equals to x square plus 1. Okay, if f of x equal to x square plus 1, then for 1 1 we need to prove, for 1 1 same thing, let x1 x2 belongs to R such that f of x1 equals to f of x2. What is this one? X1 square, the value of f of x1 is x1 square plus 1, we need to put in this equation. Okay, and here x2 square plus 1. Clear? So what we have, x1 square minus x2 square equal to 0. So what we have here from here, x1 minus x2, x1 plus x2 equal to 0. So from here we have two conditions. First one is x1 equal to x2 or x1 equal to the minus x2. Observe that here this condition is also true, this condition is also true, because it is a collection of all the real numbers, collection of all real numbers set R. So here if I am choosing, let x1 is 2, then x2 is minus 2. So obviously if we are choosing these two number, then guarantee this thing is not true because these are not equal, as 2 is not equal to minus 2. So this condition will hold. Okay, if this condition is hold, and also when we observe that f of 2 is 2 square plus 1, that is 5. F of minus 2 is also 5. So different element have same image, it means that f is not 1 1. Okay, f is not 1 1. Same thing we can prove for onto. From here, for onto, what we can tell, observe, our function is x equal to x square plus 1. We know that x square is greater than equal to 0. So x square plus 1 is greater than equal to 1. Okay, so what it implies, it implies that function value is greater than equal to 1, and this will happen for all x belongs to R. It means that what it implies, it implies that negative real number not, even 0 is also not in the range, negative real number not in the range. If it is not in the range, what it implies, range of f is not equal to R, that is codomain set. And if range is not equal to codomain set, it implies that, what it implies, it implies that f is not onto, because every element of codomain does not have preimage. Precisely, negative element does not have preimage, and also 0 does not have preimage. Okay, so I hope you understand. It means the function is not neither 1 1 nor onto, the second one, while the first function is bijective, 1 1 as well as onto. Now the next question is, let a and b be sets. Okay, functions defined from a cross b to b cross a. Okay, and then they said such that f of a comma b equals to the b comma a is bijective. We need to prove it is bijective. Okay, function is defined from a cross b to b cross a. Okay, and how they define, a comma b, b comma a, they're equal. Okay, so for 1 1, what we need to do, for 1 1, for 1 1, let x1 comma x2 belongs to a cross b. We need to choose two element of the domain set. Okay, and we need to assume this condition also, f of x1 equals to f of x2, f of x1 equal to f of x2. So but here first of all we also need to give how the x1 is looking. X1 is looking in a1 comma b1 type, and how x2 is looking, a2 comma b2 type. Okay, in which a1 comma a2 belongs to a and b1 comma b2 belongs to b. So what we have here, f of a1 comma b1 equals to f of a2 comma b2. So what we have here, from according to definition, we need to write in a reverse format, b1 a1 equals to b2 a2. And if these two ordered pair are equal, then it means that their first element compared with first, they have both has to be equal, and the second is equal to the second element. Okay, so the first b1 equals to b2 and a1 equals to a2. So what it implies, it implies that x1 equals to x2 if these things happen. Clear? And hence what we are prove here, f of x1 equal to f of x2, then x1 equal to x2 we have. It implies that f is one function, one function. Now for onto we need to prove. For onto what we have? For onto what we need to prove? We need to check every element of codomain has preimage or not. Every element of codomain. Okay. The element of B cross A, let y equals to B comma A belongs to B cross A, in which small b belongs to capital B and small a belongs to capital A. Okay, so we observe that yes, for this element we have yes, there exists x belongs to A cross B, and format of x is A comma B type, such that f of A comma B equals to B comma A, or f of x equals to y. If for each element of codomain we have preimage x, then we say f is onto, implies f is onto function. And if f is onto, clear, here f is 1 1 as well as onto, it implies that f is bijective. F is bijective function. Okay, I hope you understand all three questions. If you have any doubt in any step, then you can do comments. I will resolve your query. Thank you for watching.